Question 8, Part B. A particle moves in a straight line. At time t seconds, its distance x meters from a fixed point O on the line is given by x equals sine of 2t plus 3. Part 1. Sketch the graph of x as a function of t for t greater than or equal to 0 and less than or equal to 2 pi. The graph of x equals sine 2t plus 3 is a sine curve with amplitude 1 since the coefficient or the number that multiplies sine 2t is 1. The period is pi, which corresponds to the width of one full sine curve. And we get that by dividing 2 pi by the coefficient of t, which in this case is 2. So 2 pi divided by 2 is equal to pi. And the line of center is 3, which corresponds to this term here. We can think of this plus 3 as a vertical translation of the curve x equals sine 2t vertically upwards by 3 units. Here is a sketch of the curve x equals sine 2t plus 3. Notice the line of center here at x equals 3. Notice also there are 2 repetitions of the sine curve from 0 to 2 pi. So one full sine curve from 0 to pi and another sine curve from pi to 2 pi. Notice also the maximum values that occur at t equals pi over 4 and 5 pi over 4. And the maximum value in both cases is 4. So it's 1 unit above the line of center. Notice the minimum values occur at 3 pi over 4 and 7 pi over 4. And the minimum value is 2, which is 1 unit below the line of center. Part 2. Using your graph or otherwise, find the times when the particle is at rest and the position of the particle at those times. From the graph, the stationary points correspond to when and where the particle is at rest. Referring to the graph that was drawn in part 1, there are 4 stationary points, and these points correspond to when the particle is at rest or when the velocity of the particle is 0. And they occur at pi over 4 seconds, 3 pi over 4 seconds, 5 pi over 4 seconds, and 7 pi over 4 seconds. Now the question is also asking for the position of the particle at those times. So from the graph in part 1, the particle is at rest 2 meters from fixed point O at time t equals 3 pi over 4 seconds and time t equals 7 pi over 4 seconds. The particle is also at rest 4 meters from fixed point O at time t equals pi over 4 seconds and time t equals 5 pi over 4 seconds. Part 3. Describe the motion completely. The particle oscillates, in other words, goes backwards and forwards from 2 meters to 4 meters from fixed point O around the center of motion of 3 meters every pi seconds. We can also state that the particle has positive acceleration in the intervals t greater than pi over 2 and less than pi seconds and t greater than 3 pi over 2 and less than 2 pi seconds. We can observe this from the graph. Firstly, the oscillation, we can see that the center of motion here is 3 meters and the particle will oscillate from 4 meters down to 2 meters back to 4 meters again around this center of motion. And we can also see that the acceleration is positive from this point to this point and also from this point to this point. In other words, the points where the curve is concave up or the value of the second derivative is positive.